Hey guys, today we're going to be talking about lesson 3.2. It's about the power rule for taking derivatives. So yesterday we learned the definition of derivative and learned a little bit about what it means. And we saw that if you have a function called y equals x squared, the derivative, y prime, is just 2x. Today we're going to learn that this is part of a larger pattern. Anytime you have a basic function written like this, f of x equals x squared, you can take the derivative f prime of x by doing this. This is 2x or 2x to the 1. If it's f of x is x cubed, then the derivative is just 3x to the second power. If it's x to the fourth, then the derivative is 4x to the third power. If the function is x to the fifth, then the derivative is 5x to the fourth. Interesting, there's definitely a pattern at play here. In fact, every time, all I did was bring the exponent down as the coefficient, and the new exponent is just subtracted by 1. So here's what that looks like. The general power rule is written as follows. If f of x is x to the n, then f prime of x, the derivative, is just n, new coefficient, times x to the, just take 1 off the exponent, x to the n minus 1. That's the general rule for power rule. So let's look at some easy examples. And it works for both positive and negative numbers, which is nice. It's very handy. So easy examples. Let's look at y equals x to the 37th. If that's the function, y, then y prime, the derivative, equals, let's follow this rule. Bring the exponent in front, 37 times x to the new exponent is just 1 less, n minus 1. So it's 36. Easy. Derivative, done. Second one, if you have y equals x to the 9th, bring 9 in front. The new exponent is 8. Don't forget to keep the x there. Okay, y prime, the derivative is 9x to the 8th. Now these examples aren't as easy, but the power rule still applies. You just might need to rewrite it. Like this is 1 over x. Yeah, this is x to the 1, but you can't just do power rule if something's in the denominator. You need to rewrite it. So let's rewrite it as y equals, if you have a variable in the denominator, you can bring it up as long as you make the exponent the opposite. So instead of 1 over x to the 1, it's just x to the negative 1. Okay? Now once we rewrite it like this, we can use the power rule. Y prime, the derivative, equals, bring the negative 1 in front, x, and now the new exponent isn't 0. Okay, that's not adding 1, you're subtracting 1. So the new exponent is negative 2. And now we rewrite it. We don't generally leave negative exponents. We want to simplify. So the derivative function is negative 1 over x squared. Because if you have a negative, if you're left with a negative exponent, you could throw it downstairs and make it positive. But make sure you write the whole thing as a fraction. Negative 1 over x squared is the derivative of 1 over x. Number 4, same deal. 1 over x to the 4th, you cannot ever just use the power rule in the denominator and call it a day. Okay? And I'll show you why in a second. So let's rewrite it. Y equals, let's see, x to the 4th in the denominator. That's like just saying x to the negative 4th. So now it's a basic expression we can use power rule. Y prime. Remember, this right here is just a rewrite. It's not the derivative. The derivative is what we're going to do using the power rule. Bring the negative 4 in front. X to the negative 4 minus 1. Negative 4, this exponent right here. Subtract 1. It's now negative 5. And that's kind of messy. We don't leave negative exponents again. So y prime equals negative 4 is the numerator over x to the 5th. You could also have written it as negative 4 as a coefficient times 1 over x to the 5th, but this is a simpler version. Okay? Now, what would have happened if you just did the power rule? This does not equal. Did the power rule in the denominator? You'd get 1 over 4x to the 3rd. That looks nothing like the answer if you compare it. So no, you cannot just use the power rule in the denominator. You have to rewrite it as an expression that looks like a single term. How about this one? Square root of x. Well, how are we going to do that? I need something that looks like x raised to a power. Well, the good news is a square root of x can be rewritten as a power. Remember, all radical expressions can be rewritten with rational or fractional exponents. So let's rewrite it. Y equals, let's see, square root of x is really just x to the 1/2, because this is the square root for a reason. There's a little 2 there that we just don't always write. And the exponent of the x is like 1. So that 1 goes into the numerator, 1. And the 2 from the square root goes in the denominator of the exponent. Now we can use power rule. That was just a rewrite. Now we're going to find the derivative. Y prime equals the 1/2 in front. You have x raised to the, let's see, 1/2 minus 1. Okay, that's just negative 1/2, isn't it? 1/2 minus 1. It's like 1/2 minus 2 over 2. And then now again, we have a negative exponent. I want to rewrite that a little bit cleaner. So y prime, the derivative, equals, let's see, 1 over 2 is in the denominator, and I'm going to move that x to the negative 1/2 down, make it positive 1/2. But here, then again, we can write this in a simpler way. Because I already know x to the 1/2 is square root of x. So I'm just going to rewrite it as 1 over 2 radical x. Okay. Let's try this one. A little bit more complicated, but the same procedure here. Rewrite it so we can use power rule. Y equals. I love things that are in just x raised to some number format. So there's an x. The numerator is 3 of the exponent, and the denominator is the 7, 3/7. All radicals can be rewritten like this. And I suggest you do that for the derivative. Okay, so now let's take a derivative. Y prime equals, okay, this shouldn't be too hard, 3/7 x. If I have 3/7 and I subtract 1, that's like 3/7 minus 7/7, right? Because 7/7 is 1. That gets you negative 4/7. And again, we're going to rewrite that because negative exponents, we generally don't leave them. They're harder to use in the calculator and things like that. Y prime equals, let's see, 3 is in the numerator, the 7 is in the denominator, and now you have an x raised to the, let's make that positive since we're moving it downstairs, x to the 4/7. And now this is pretty good, but I can simplify that even further just to rewrite it, 3 over 7, let's see, x to the 4/7, this thing right here. I need to go backwards and make it look like that. This is an x with a radical. It's the 7th root of x to the 4th. That is the derivative, y prime. Okay? You could leave it like this, but it's simpler to write it like that. Good. And remember, at any point, feel free to pause this video if you need to wrap your head around stuff we're doing. Now, there's a constant multiple rule. What if there's a constant sitting in front of that expression, like 7 x to the 5th? Well, the constant can be factored out. So this, I don't need to rewrite it. It's written nice. I just need to write y prime, or in this case, they call it dy dx. Same thing. Let's call it dy dx. It's a different form. 7. Leave the 7 factored out. And then now let's just do the power rule on this x to the 5th. Well, now we know power rule. It says bring the 5. It's times, still coefficient, x to the 4th. Now you're probably, as you do more of these, you're not going to show this middle step. You're generally not going to show this at all. You're just going to multiply the 7 and 5 right off the bat. right? You're going to multiply the 7 times 5 right off the bat. So you get 35 x to the fourth. A shortcut there being, just take the 5, multiply it by the 7, and of course drop the exponent down by 1. 5 times 7 is 35, times x to the fourth is the new exponent. Okay? That is a simple power rule. This one. Try this one. Pause the video, try it, and I'll reveal the answer. Hopefully you tried it, and more importantly, hopefully you got this. 6x squared. The long way to do it is just to factor out the 2, leave the 2 out. Oops, you know what? Let's call this y prime, or dy dx, same thing. They both mean derivative. Leave the 2 factored out, and then just do power rule on x to the third. That is a perfectly valid way to do it. But look, the 2 times 3 is just 6. So you can just jump to the 6x squared if you have a basic expression like this. Cool. Try this one. Pause the video, try it, come back. Hopefully you tried it, and hopefully you got this. 12x squared, right? Pretty straightforward. Exponent times the coefficient is 12. The variable is x, and then 3 was the old exponent. The new exponent is 2. Derivative. Since they called the function f of x, same thing as y equals, it's just written, the derivative itself is written a different way, f prime of x. Remember, all those things mean the derivative. Okay? So next up, that's the constant multiple rule. You don't need to know the name of it. Just know that if there's a constant, use it. Now there's also a sum and difference rule. It says when finding the derivative of a polynomial, you just do one term at a time. So if y, the function y is x to the fourth plus 12x, remember this is like 12x to the 1, if you will, well then you get, just use power rule, 4x to the third. I just differentiated this first term, and now there's a plus, and I'm going to differentiate this next term. That's just 12 times x to the 0, right? If I take away 1, but x to the 0 is just 1. So I don't generally need to write it. It's 1. 12 times 1 is just 12. Y prime, aka the derivative. Very straightforward. Try this one. Try this one, pause the video, come back. Okay, welcome back. Here we go. I'm going to differentiate each term separately. 4x to the third minus 2x squared. Well, okay, I could do power rule there. 4x. And now, interesting. Plus 2. What do I do with that? Well, let's figure out what to do with that. I'm going to come back to that in a second. Constant function rule. Again, it's a rule you don't really need to know the name of, but let's talk about what if you have a constant function. Remember, derivative is the slope. We talked about that yesterday. So let's look at a constant function called f of x equals 3 or y equals 3. Hopefully you know what that is. That's just a horizontal line. And that red line right here is my best attempt at a straight horizontal line. F of x equals 3 is just that constant line right there. Now look, at any given moment, if derivative is slope, which I emphasized yesterday, let's see at negative 3. What's the slope here? Well, it's 0. What's the slope at, let's say, 0? Well, it's 0. Slope at 1, 0. Slope at 2, 0. The slope of a horizontal line is always 0. Therefore, the derivative must be 0. There it is right there. The derivative of a constant is 0. So if you have f of x equals 3, f prime of x is just 0. And that works for any constant. Even if it's a horizontal line down here, if you have y equals negative 5, derivative is 0. That's a good thing to keep in mind. So let's go back up here. The plus 2. Well, if derivative is 0, then I can write plus 0, but why would I need to do that? Leave it off. The derivative of a constant is 0. So when you take the derivative, you don't need to put anything there. Okay? your derivative. Cool. So having said those rules, I want to look at yesterday's examples real quick. Yesterday we did, this example right here. I showed you how to do the long way. I told you that in previous years, I've made kids do the long way for at least a week using the definition of derivative. I said this year you can stop right here. The setup is what I care about if you know how to use the formula for derivative. Well, we did all this. We went through, we did the algebra, we expanded, we canceled, factored out an h over here, so they canceled. Then we were left with the derivative. All that work just to say that the derivative of x squared plus 2 equals 2x. So you're telling me if f of x equals x squared plus 2, instead of doing all this, the power rule says f prime of x, let's use power rule. X squared, I'll differentiate that first. You get 2x. Differentiate 2, that's 0. Look, I got f prime of x equals 2x. I told you there was going to be a shorter way. This literally takes under 10 seconds, as opposed to doing all this. Okay? So that's pretty sweet. Power rule is very useful, especially given what we learned about the derivative, all the cool things it does. Okay? We talked about how it can find the slope at any point of a curve, which means it can find the instantaneous rate of change or the instantaneous speed of an object moving without a speedometer if you can take the derivative. This one, we set up and didn't have time to finish. Well, now let's say we use power rule on this one. X squared minus 4x. Let me do it here. If f of x is x squared minus 4x, then f prime of x equals 2x minus 4. Easy. And if I did all this algebra and went through this and did all the steps, I promise you I would get 2x minus 4. The power rule saves you a lot of time. Okay? Good. And we just kind of did one, but if you have a linear function, let's talk about the derivative. F of x equals 3x plus 1. Well, I drew it here in red. At any point on this line, what's the slope? Slope here, let's see, up 3 over 1. The slope is 3. Slope here, it's 3. Slope here, it's 3. I promise you. That's what defines a line. It's got a constant slope everywhere. The slope is always the same. So the derivative, f prime of x, is just 3. That works via power rule or via the graph. Same thing here. In blue, I drew negative 2/3 x minus 4. At any given point, what's the slope of this line? Well, that is down 2 over 3, negative 2/3. This is negative 2/3, down 2 over 3. Here, literally at any point I can pick on the line, it's negative 2/3. So f prime of x is just negative 2/3. So if you have a linear function, the derivative must be the slope, right? Power rule even tells us. Remember, you could treat this as 3x to the 1 plus 1. Okay, well, that's easy. 1 times 3 is 3. And then x to the 1 minus, if the exponent reduces by 1, it's x to the 0, but x to the 0 is 1. So you don't need it. Hopefully that makes sense. Power rule is powerful. Okay, finding the slope of a tangent line. So they give me a function called g of x. It's a 4-term polynomial, 4th degree. Great, awesome. Find the slope of the tangent line to g of x at x equals 2. Well, I told you, a bunch of things mean the same thing. Slope of the tangent line, the slope of the curve, the instantaneous rate of change. They all mean the derivative. So when it says find the slope of the line to g of x at x equals 2, I'm saying find the derivative g prime and just plug in 2. And that will give you the slope of the tangent line without ever looking at a graph. So let's do that. Let's find g prime of x, shall we? And then we'll just plug in 2 later at the end. You can't plug in 2 first. Because if you plug in 2 first, well, that's not going to help you. That's just going to give you the function value at 2. That'll tell you how high up it is, the altitude, if you will, the y-coordinate. We take the derivative, and then we're going to plug in 2 into that. So let's take the derivative of each piece like we usually do. X to the 4th, okay, that's 4x to the 3rd, right? Use different colors for each. 2x squared, okay, that's a plus 4x to the 1, or just x. And then, let's go green, negative 3/4 x. Well, we just talked about that. That's a linear term, so the derivative is just negative 3/4. And then, minus 19, well, we talked about that too. The derivative of a constant is 0. So that's done. It's not there. So now we just found the derivative, guys. This is the derivative. Congratulations. But they want to know the slope of the tangent line at 2. Well, this derivative is a magical formula because it will now find the slope of a tangent line at any point you desire. Literally any point on the coordinate plane. On the x-axis, you can plug it in and it'll tell you exactly the slope of the tangent line at that point. The only point I care about right now is 2. So, g prime of 2. Plug in 2. Do it in your head or write it out. 4 times 2 cubed. That's 4 times 2 minus 3/4. This is 4 times 8 plus 8 minus 3/4. So this would be 32 plus 8 minus 3/4. 40 minus 3/4. And by no means would you probably show all this work when you're doing it. Probably just do whatever steps you can in the calculator. This gets you essentially 39.25, right? You can write that as an improper fraction if you want. You can write it as 39.25. Okay. What would the improper fraction be? Let's see. 40 would be like 160 over 4 minus 3/4. Improper fraction would be 157 over 4. Literally, all 3 of these things mean the same thing. They're all equivalent, so they are all correct. And you should write g prime of 2 equals. And it couldn't hurt to write, this is the slope of the tangent line of g of x at x equals 2. You just found it using the derivative. Okay? Okay, I want you to try the homework. I think it's 10 problems, and you've seen how quickly Power Rule can find a derivative. That's all it really is. So give it a try. I'll be around tomorrow. Feel free to ask me any questions, okay? Any comments, message me, or I'll see you in class tomorrow. If not, do the homework, and tomorrow you guys can work on this.